Guys, today we're going to talk about prime factorization, and this should be a review from you. This should look very familiar from last year in 5th grade when you were learning how to add, subtract, multiply, and divide fractions. You probably learned about prime factorization. So the I can statement we're working on is I can write the prime factorization of any composite number. So let's review what that means. Let's break down the term prime factorization. Factor, you already know. Those are those whole numbers that evenly divide into other numbers. So the factors of 12 are 1 times 12, so that's how we have 1 and 12 here. 2 times 6, so 2 and 6, and 3 times 4, 3 and 4. Don't forget, the biggest mistake I see is people forget the factor 1 and itself. Those two are always factors. Now let's look at the word prime. Prime numbers we talked about are those numbers that have exactly two factors, 1 in itself. Like 13 has 1 and 13. That's it. Nothing else can divide 13 evenly. So let's review our prime numbers. We looked at the dimensions of a rectangle with an area of 24, and we came up with 4 different rectangles. And we said, therefore, these dimensions ended up being factors of 24. And so in this case, we have 8 factors of 24. 1, 2, 3, 4, 6, 8, 12, and 24. Then we looked at a rectangle with an area of 13, and we could only make one with different dimensions, which were side lengths of 1 and 13. And so we determined 13 must be prime because it has exactly 2 factors, 1 and 13. So numbers that have exactly 2 factors we know are called prime numbers. Let's look at a couple. You also have your list you can look back on. And then we have those composite numbers that have 2 or more factors, or more than 2 factors, sorry. And you have a whole list of those, all the ones that you crossed off on your sieve the other day. So prime factorization of a number consists of factors that are prime numbers, and we like to imagine an upside down tree. Now let's look at 24 because that's a number that we are familiar with. And when we make our tree, the trunk of the tree would be our composite number, which is 24. And then the branches are the factors of 24. So 6 and 4. Now there are other ones we could have chosen, and we're going to come up with the same answer. We'll look at that a little later. But right now, we're going to pick 6 and 24. Now 6 and 24 are both composite, so I can break those down. 6 can be broken down into 3 times 2, and those would be the leaves of the tree. And 4 can be broken down into 2 times 2, and those are prime. So those are the leaves of the tree. Sorry about that. So the leaves on the trees are the prime factors of 24. And so we have 3, 2, 2, 2. So 3 times 2 times 2 times 2, that's the prime factorization of 24. But that can also be broken down or rewritten using exponents. So there are 3 2's, so we would say 2 to the 3rd power times 3. So 20, that's another way we can write the prime factorization. Either way you want to write it for this class is fine with me. So let's try one more. Prime factorization of 36. If you think you've got it, go ahead and pause and try it out. Okay, let's see how you did. I can break 36 down into 6 times 6. Now you might have done something a little different, and that's okay. Check and see if your prime factorization is the same as mine. 6 we know can be broken down into 3 times 2, and the other 6 can be broken down into 3 times 2 or 2 times 3 because it's commutative. It doesn't matter which order I write them. And now I've got my prime factorization. 36 equals 3 times 2 times 2 times 3. And when I rearrange those numbers and rewrite them using the distributive or using exponents, I might want to use the commutative property to shuffle them around. So I've got all my 3's together, all my 2's together, and I get 3 squared times 2 squared. And that's another way to write the prime factorization of 36. So let's do some practice. First of all, let's just look at this expression. Could you rewrite this expression using exponents? Pause and give it a try, then we'll check it out. Okay, let's see how you did. There were 3 2's, so you'd get 2 to the 3rd, 2 3's, so 3 squared, and 3 4's, so 4 to the 3rd. So your prime factor, or your rewritten expression would be 2 to the third times 3 squared times 4 to the third. Try this one. This problem is going to require you to use the commutative property. So when we look at all the numbers that are the same and put them together, I see that I have 1, 2, so 2 times 1, 3 times 4 to the fourth, because there's 1, 2, 3, 4 fours, times 5 squared, because there's 2 5s. Try this one. Find the prime factorization of 40. Okay, let's check your work. Here is one way you could have done this. And if I took those leaves, I would have 2 times 2 times 2 times 5, or 2 to the third times 5. And you would check your work by evaluating. So I would take 2 to the third times 5, and I would work it out, and I would get, you should get 40 when you work it out. Because factoring and evaluating are inverse operations, which means they are the opposite of each other. They help each other out. If I want to factor something, to check it, I evaluate. If I evaluate something, I might want to check it by factoring, sometimes. This one has a mistake. Pause, figure out the mistake, and then correct it. Okay, let's check your work. You might have noticed that we're fine on this side of the tree, but 10 is not 5 times 5. Factoring implies multiplication, not addition, so that should have been 5 times 2, which would give you, 2, 3, 5, and 2 as your prime factors. Look at this one. Jack and Jill are both making factor trees for the number 12. Jack begins with 2 times 6. Here's Jack. And Jill begins with 3 times 4. When Jack and Jill write the prime factorization of 12, will their answers be the same or different? Let's see what you thought. Even though these appear to be different, when they get worked out and completely factored, they have the same leaves on their tree. And their prime factorization, both Jack and Jill, got 2 to the third times 3. What if Jack found the prime factorization of 24 and said it was 3 times 8? He made a mistake. Take a minute, explain and correct his mistake. Okay, let's see how you did. You should have noticed that 8 is not a prime number and therefore has to be broken down again. So instead of 8, he should have had 2 to the third, or 2 times 2 times 2. All right, that's the end of our video. You can go back and watch any part as many times as you need to, or the whole thing, but don't forget to WSQ in your notes.